Welcome back to Learn with me, Ms. Killen, here at MPB. We are in our second lesson of this Unit 1, our numbers and expressions. So I want us to see that we are doing significant digits, and I can interpret appropriate quantities for the purpose of describing models. So I also want us to know these are our standards in Q1, 2, and 3. So we always need to make sure that we're understanding what standards we're working with and what we can do within those standards. So let's go into the unit. Okay, so some new vocabulary that we're going to see is significant digits, non-zero digits, and we'll get rules for these significant digits. Now, one thing that I want us to note, when we are in our biology classes, our significant digits will sometimes be referenced significant figures. So when you're in those biology classes and like, we've done this before, I want you to know that they go hand in hand. So here we go. The number of significant digits in a number reflects its precision. Now we know precision as being accurate or precise. Essentially, the more significant digits a number has, the more precise or the more accurate that we are when we're dealing with these different numbers. We have rules for these significant digits, non-zero digits. Now, you may be sitting there asking yourself, what is a non-zero digit? Well, it's just what it sounds like. It's not a zero. One forever. So I want us to make sure that we know the difference between zeros and non-zeros. You would think, well, Ms. Killen, that just kind of goes, with what we know. Some people have a little bit harder understanding of what that non-zero means. We know what not zero is, but we're not quite sure about non-zero. So I wanted us to make sure that we compared them. So zeros that are between digits are significant. Leading zeros are not. So if I had a number that was 0 point blah, 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 the zero in front that's leading is not going to be significant. Now, trailing zeros, they are significant. It helps be more precise or more accurate. And decimals, when we have a decimal, I'm going to read from left to right, but if I do not have a decimal, I'm going to read right to left. So let's consider these numbers. Let's get into our notes and our examples. So when I look at this number, 0.059810, I'm going to ask myself, what is the number of significant digits? Now we saw that our leading right here is not a significant digit. Our trailing is a significant digit. So if I counted 1, 2, 3, 4, 5, I have 5 significant digits. Now let's look at the next one. I have some leading zeros, and we know that leading zeros are not significant digits. So I have 1, 2, 3. So I have 3 significant digits here, or sig figs, as you may hear them in biology. Let's look at this last one. I have 120.05. Now I've got zeros and I've got decimals. So I need to make sure that I'm understanding how those decimals are looking when I have them inside my numbers, when they're between non-zero digits. So when I look at this, I have a decimal, so I'm going to read from right to left. So I have 1, 2, 3, 4, 5 significant digits. That's a tongue twister. So like I said, in science, you're going to hear significant figures, sig figs, they're all the same. You're looking at those different numbers and you're having to look at the leading zeros or the trailing zeros. So you want to make sure that you can know the difference between those leading and trailing zeros. Good job. All right, so now it's time for you to master. I want us to tell how many significant digits in each of these following numbers. So go ahead and pause the video. You can work by yourself or with your table partners, and when you get done, come back to me and let's see what we got. All right, so let's see what we got. I'm looking at this first one. I don't have any zeros, so what I'm going to do is I'm just going to start and count. Since I have a decimal, I'm going to count from right to left. So I've got 1, 2, 3, 4, 5 digits. Now let's look at this next one. It looks a little different. I've got a whole bunch of zeros in this one. Now we heard and learned and saw what happens when I have leading zeros, and we've also seen what happens when I have trailing zeros. So I'm looking at from right to left, 1, 2, 3. I'm going to have 3 significant figures or significant digits. Now, 700,000, don't we wish we had that in money? Yes, we do. So I don't see a decimal in this number. There's no decimal. So what did we say we looked at when we do not have a decimal? Exactly right. We're going from left to right now. So I have 1 significant digit, just 1. All right, let's look at the last one. I have a decimal, so I'm going to go from my right side to my left side. So let's count. 1, 2, 3, 4, 5, 6 significant digits. Does yours look like mine? If not, turn to your table partner. Y'all talk about it and see what we did, what maybe we didn't see, and let's compare. We always want to make sure we're looking for decimals. If decimals, right to left. We're also looking to see if we have leading zeros or if we have trailing zeros. You always want to make sure that you're noticing all of this. All right, so I don't want us to forget what significant digits look like. How are they written? Do I have trailing zeros? Do I have leading zeros? We also need to remember how those zeros work with insignificant digits. If those zeros lie between non-zero digits, we need to know what those look like. And we also need to remember what non-zeros are. Remember, in science, in your bio classes, you're going to see sig figs or significant figures. So all of this is going to be the same concepts. I'm so glad that you came to work with me today here at MPB. I'm having a great time learning this algebra with you. Thank you, and I want you to have a great day.